and gentlemen, Sentinel-3A has lifted off into space, and I'm sure you'll agree that was a very impressive flight. Now, of course, we're entering into an exciting early phase of the flight, which is going to be shown here on our screens.
Thrust power that the rocket has, it has twice the thrust to lift, twice the thrust that is needed to actually lift the rocket. And now we see here already the first flight takes about 2 minutes, and the first stage flight takes about 2 minutes, and then the first stage separation takes place. So that is actually what we see in this animation, and what we see as well is basically all the maneuvers that the rocket is performing during ascent in an animated version.
Okay, and so of course we are now 3 minutes into the flight of the Rokot. How does the data of its position come down from the rocket to us here?
We are actually using telemetry that is downlinked from the launcher to Russian ground stations. Just a remark, that is the indication that at that time we're expecting payload-fairing jettisoning. That is taking place at about 120 kilometers of altitude once we have left the atmosphere. So coming back to your earlier question, the telemetry is basically downlinked to Russian ground stations that are located on Russian territory. That is also a reason why we're later on losing visibility. That is absolutely normal, and that only indicates that we are going into a flight path that is on the other side of the world, seen from the Russian territory, so that we don't have telemetry only shortly before we have separation.
Now we're seeing all of the different stages coming off there. Can you tell us why it doesn't all happen in one go? Why is it happening in stages like we've seen?
Well, that is a way to optimize the efficiency of a rocket. So a rocket mainly consists of fuel that is needed to accelerate the payload, and you need a bit of a structure to put fuel into, and you need an engine. But once you actually have burn down all the fuel, then you can get rid of the heavy structure, and you go over to a smaller rocket which is then fired again. So at this point we are flying the second stage, which will be fired for about 3 minutes, and then it will be separated as well, and then only the breeze upper stage is continuing the flight and is putting the spacecraft into orbit.
So what happens when the breeze upper stage comes away? Can you talk us through that?
Well, it actually continues what the first two stages have done so far as well. It will enter into a 10 minutes acceleration phase as well. It will disappear into a zone where there is no visibility, so we actually don't have space to bring the spacecraft into orbit. And
what are we seeing here with this graph before?
This graph that is on right now, and which is... Well, that is basically showing the flight path, and it gives you an illustration. I'm not sure if you can see. You see these trajectories plotted on the world map. You see we're starting from Plesецk. We're going north towards the pole. We travel above Greenland, and then we come down over the North American continent, Pacific, and about 1.5 hours, 1 hour, 20 minutes later, we will come up again over the equator, and that is the point where we'll expect a separation of the spacecraft.
Well, I've just heard as well that we're now in the first burn of the breeze, so that's good news. Everything seems on track, and we've entered into the cruising phase now. So at this point, I'd like to thank you very much for talking through everything with us, Matthias Muck.